Okay.
Okay.
All right. So can you see my screen?
Yes.
Okay. Last time on quadratic, we talked about finding finding the equation, and we said that there are two types. Okay.
Yes.
There
The
are,
one
I'm listening.
the one where we use simultaneous uh equation
Yes.
and okay. And
So
when we are given 2 points.
exactly when we are given two roots. So the first one we talked about, uh, let me quickly do this. Okay, so we set on finding the equation. Okay, so we set on finding the equation. The first one, you will be given what? You will be given the turning point, and the turning point is in the form of 0 and what? And q. We also talked about and another point. We said the turning point and another point. Can you see my writing?
Yes.
Therefore, which equation do we use? To find the equation, we're going to use y is equals to ax squared plus q. Okay, so we had an example there where we were talking about the finding the equation, and the example looked like this. So we had the turning point as 4 there, and then another point here was -2 and -8. That's what we did last time. So we said to
Yes.
find the equation of this, we're going to use the equation y is equals to ax squared plus q. Okay, and we said that you need to first substitute the points, the y value. We talked about the y value being the this y value here being the value of q. So the y value of the turning point, as you can see, the coordinates of the turning point is 0 and 4, meaning the value of q. This is the value of q. We just have to substitute that on the equation. Where there's q, we need to put that 4, which gives us y is equals to ax squared plus 4. Are you happy with that?
Yes.
Then after substituting that point, this is where you can sub you can now sub the coordinate -2 and -8. But you need to pay attention on the coordinates. This is your x and this is your y value. So on this equation, where there's x, you put -2, and where there's y, you're going to substitute x. Okay, so where there's y, I'm going to put -8. This is equals to a, where there's x, we put -2 squared plus 4. Okay, so if you still remember, from this point, the aim is to make a subject of the formula, bring the 4 this side to be negative. This will be -2 squared, that's 4. So this will be 4a. This will be -16 equated to 4a, making a subject of the formula. I can divide both sides by 4. So dividing both sides by 4, therefore the value of a is just -4. So now that you have the value of a, what should we do next? To write down the equation, we need to substitute this back. So the equation will be y is equals to -4x squared and plus 4. So that's the equation of the graph. Are you happy with that?
Yes.
This is what we talked about on the previous lesson. Then we also talked about having This is just a quick revision on what we did here last time. So the second one, we said you might be given the roots, okay? You might be given the roots, which is the x-intercepts, and then and another, oh, and another point. So we said that if you are given the roots, to find the equation, we use the y is equals to a into x minus the first root into x minus the second root. That is the equation that we're going to do. So if you are given the roots and 1 point, this is the equation that you need to use to find the equation of that graph. And we definitely talked about the example where you have something like this. I just want to make sure that we get this right. That's why we are doing this again. Minus
Yes.
4 and 4. This is your x, this is your y. Then let's say other point here is given as 6 and 10. So now, in order for you to work this thing out, you're going to do the substitution correctly from this equation, okay? You first substitute your roots. So this will be y is equals to a, therefore inside the bracket, x minus root 1. This is your root 1, and this will be your root 2. But root 1 is negative. You need to put it inside the bracket. This is very important. Then this is multiplied by the second one, which is x minus root 2, which is just 4. Okay, so now, remember, last time I said that the a will multiply what? Everything inside these two brackets. So the a multiplies everything inside. That's what we talked about. So now when you look at this, what we have inside, we need to multiply out the bracket here by negative and a negative, which will give us x plus 4 into x minus 4. Therefore, everything here should be multiplied by a. Right. So if you are happy about that, what should we do next?
We're going to do, what is it called? Dots. No, not dots. We're going to multiply out.
The bracket.
Yes. So x times x is x to the power of 2, and so on, so on.
Exactly. We do the FOIL method. So this will be x times x, that's x squared, minus 4x, then plus 4x. When you do the FOIL method, this is what you're going to get. Then you add the like terms, they just give you 0, since they are the like terms with different signs. Therefore, this is multiplied by a. Therefore, what is y? Y is just a into x squared minus 16. Then from there, the aim is to find the value of a. So if I have this, okay, if I have y to be equals to a into x squared minus 16, I need to now substitute. I need to substitute that given point, the 6 and 10, into that equation. When you substitute the given point, I need you to pay attention. This is your x, and this is your y, meaning on this equation, where there's y, you put 10, and where there's x, you're gonna put 6, and this 6, it is squared minus 16. 6 squared, that's 36. So this will be a into 36 minus 16, which is 20, and this is equated to 10. So 10 is just 20a. Divide both sides by 20 to find the value of a, because the aim is to find the value of a. Therefore, I can conclude and say a is equals to half. Are you happy with that?
Yes.
So now that you have a, from this equation, you substitute a to write down the equation. So y will be equals to 1 over 2x squared minus 8. Are you still with me? Do you understand how we did this one?
Yes.
Okay, 100%. So now that you understand how to find the equation of the graph, we need to work on sketching. This is what we need to focus on this lesson. We'll be working on sketching. Okay, so we'll be working on sketching the graphs. How do we sketch the quadratic graphs? Okay, so when you sketch, there are steps that you need to follow. The first step, you need to find your turning point, TP, or your y-intercept. You find TP or your y-intercept. That's the first thing. Number two, you need to make sure that you find your x-intercept. Your x-intercept, and in none use the table method. Then number three, you determine the shape. You determine the shape. That's how you do the sketch. So let's start with this example. Let's work on this example. So on this example, I'm going to take f at x. Let's say I'm given that f at x is equals to 2x squared plus 2. And they want us to sketch the graph. Sketch the following graph. Show all the x-intercept with the axis and the turning points. Okay. So when I sketch the graph, you know what I'm going to do?
Put it into your
I'm
calculator.
going to follow this step. Let's first find the TP, okay?
Okay.
Remember, you don't have to do any calculations. Number one, what is your turning point? Remember, turning point is always 0 and Q. So in this form, what is the value of Q in that given equation?
2.
Exactly, because this is in the form of ax squared plus Q. So the value of Q, that's 2. I think you can also see that I changed the teaching method. I even try to move slow, né?
Yes.
Therefore, the turning point will be 0 and 2. That's your turning point. You move to the second point, you find the x-intercept. Tell me, how do we find the x-intercept? In order for you to find the x-intercept, y should be equals to?
X.
No, y should
0,
be
0.
Exactly. Y should be equals to 0. So in order for you to find the x-intercept, y should be equals to 0. For you to find the y-intercept, x should be equals to 0. You understand?
Yes.
So you're going to rewrite down the equation and say y is equal to 2x squared plus 2, where there's y you put 0. Then you solve for x. You're going to solve for x. Solving for x, this gives us minus 2. We bring the minus 2 to the other side. Therefore, this is 2x squared. Is there anything that we can do here? If we divide both sides by 2, we have minus 1 to be x squared. But now look at this question. Can we solve this? Can we find the square root of minus 1?
No.
Exactly. We cannot do that. Then we're going to conclude and say, therefore, this equation has no x-intercept because this is no solution. No solution. So this tells you that has no x-intercept. So if it has no x-intercept, then you determine the shape. That's number 3. So the shape will look at the value of a, which is 2. The value of a is greater than 0. And we say that if it's positive, it will be concave up. So what you're going to do, because we need some points, you're going to use what we call the table of data points on the calculator. You can even use your calculator, né?
Yes.
Right, we're gonna do the table of data points. You can definitely use your calculator. You're gonna have your x and the corresponding y value. I'm not gonna use the calculator in this one. I'm just gonna go straight and find this thing without using the calculator. You'll help me with the calculator. So we can start at -2 and do for -1, and then do for 0, do for 1 and 2. Let's find those points and see what we get. Meaning that from the equation y is equals to 2x squared plus 2. Where there's x, you first put -2. The answer that you get, we're going to record it on the corresponding y value. Can you please put -2 on this equation? Where there's x, I need you to put -2. What do you get? I need you to practice using a calculator. It's going to be 2 into -2 squared plus 2. What is the answer? Do you know how to do the substitution?
Wait, sir. No, sir. It's 10. I was on, never mind.
Okay, so you good now?
Yes.
Try for -1.
4.
You got?
4.
Wonderful. Then for 0 is just 2, right? For 1, it's 4. When you put 2, you get 10. So now this is where you're going to start and draw your graph, okay?
Yes.
So this is your graph. You first plot your turning point. Please don't forget the turning point. This is where you're going to start. The turning point is 0:2. So it's going to be somewhere here. If I put 0 and 2, this will be my turning point. That's 0 and 2. Then -2 and 10. So maybe if I say -2 and 10, it should be somewhere -2 and 10, it should be, okay, let me start it with 0 and 2. This is my turning point. And then let's do x, it's 1 and 4. It should be somewhere here. If this is 2, this is 4, this is 1. So it should be somewhere here. -1 and 4, it should be somewhere here. They will correspond. Then we have 2 and 10, it should be somewhere there. Another 2 and 10, it should be somewhere there. Then you connect your dot. We know that the graph should be concave up. So this is how the graph will look like. So the graph will look like that. Are you happy with the drawing?
Yes.
Okay. So now on this graph, there are some of the questions that you might expect for them to ask you next. For example, they can ask you the domain and they have the range. Right. So now the domain is where we check for which values of x can your graph take. As you can see, it can take all the negative x values and then it can take all the positive x values, meaning the domain its x must be an element of real numbers. But for the range, it takes from this point going all the way up. So we start with a small number, which is 2, but it is included, we use big bracket, that will be 2 is to positive infinity. Are you getting that one?
Yes.
100%. 100%.
So the range and domain, will it differ on different questions?
The only thing that remains the same, I think that's a very good question. The only thing that will remain the same is the domain. So the domain will always be like this. X must be an element of real number. So the range is the one that depends on the value of A. You understand?
Yes.
Yeah. Don't worry, we'll work on more examples. Oh, okay. There's too much work that we need to do on the fraction. I just feel like we are not moving at a good pace, but hopefully we'll finish this soon. Let's work on the next example. Do you have any question on this one?
No.
100%. Okay.
Yes.
Now, let's do the second example of plotting a graph. Let's say you are given a graph of okay, let's say you are given the g at x, and they say this is minus 2x squared plus 8. Let's draw the sketch. So to draw the sketch, you still remember the steps that we need to take. Number one, you need to find your TP, your turning point, which is in the form of 0 and Q. Tell me, what is the value of Q in this case?
8.
Exactly. So the coordinates will be 0 and 8. So this is our turning point. Then we move to the next step, which is finding the x-intercept. How do we find the x-intercept?
By sorry, substituting. Yes.
What are we substituting?
We are substituting. We're turning y equals 0.
Exactly.
So
Where there's y, we put 0. Okay? So
yes.
meaning that if the equation is y is equal to minus 2x squared plus 8, to find x where there's y, we put 0. Then we left with minus 2x squared plus 8. Let's bring the 8 this side to be negative 8 minus 2x squared, because we are trying to isolate that x. Now you can just divide both sides by negative 2. Therefore, this side is x squared, it's equals to minus 8 over minus 2, that's positive 4. Okay?
Yes.
Then, to make x subject of the formula, what should we do next? Because I need to get rid of this 2 on top. You see the 2 on top? We need to get rid of that.
Yes.
How can we cancel the 2?
So can we divide? Actually, I don't know. Can we divide 4 with the power of 2 too?
No, but we can square both sides like this.
Okay.
The square root will cancel the 2. Therefore, x will be, please, just know that the square root of any number is plus or minus root 4. It's plus or minus, meaning that root 4 is 2, answer will be negative 2, or x will be positive 2. Do you understand?
Yes.
So these are the x-intercept if y is 0. So the coordinates will be minus 2 and 0, and the other coordinates will be 2 and 0. So these are your x-intercept. We definitely need this x-intercept in the upcoming drawing. The drawing that we're going to do, we need to indicate this x-intercept. So the previous lesson, we did not have the x-intercept, but in this one, we definitely do have the x-intercept, okay?
Yes.
Right. So when you work with this one, you don't have to find the y-intercept. The y-intercept is your turning point. So this turning point is your y-intercept. So you don't have to stress much about that. Next step, step number 3, you need to determine the shape. Look at the value of A. If you look at this, remember the equation is in the form of y is equals to ax squared plus Q. So the value of A is -2. So the value of A is less than 0, meaning our graph should have a set face. It will be concave down. Now we can definitely draw the graph. So we can just put the graph like this. This is my X, this is my Y. Then you plot your turning point first. That's your turning point. It's 0 and 8. Then you plot your x-intercept, 2 and 0, somewhere there. And then -2 and 0 somewhere there. Can you see? Plotting is very easy. Then the only thing that you can do now is to connect the dots, because you know the shape is that the graph will be concave down. So that's how the graph should look like. So it will move like this all the way to the turning point, and then it moves like this. So now this is your graph. Remember, the domain will always be X, must be an element of real numbers. The range is the one that depends on what? The turning point. So it takes from this point going down. We first write the small number, which will be negative infinity. So Y must be an element of, it starts from negative infinity all the way to 8. But the 8 is included. I'm not sure if this makes sense.
No, I understand, sir.
You get it? You sure? Because I want to prepare a task for you that you can work on some of the questions that I need you to practice, okay?
Okay.
Okay, so now I'm going to use the remaining. Remember, we are not longer doing 1 hour lessons. I just want our lesson to be very short, so that I don't give you too much information on a session. So now I'm going to introduce you to hyperbola. Then on the upcoming lesson, we're gonna start doing how to sketch a hyperbola. So I'm just gonna go through with you the introduction to hyperbola. Okay.
Okay.
Okay. So now this was a quadratic equation, also known as parabola. The next type of function that we're going to work on, we call it hyperbola functions. So this is hyperbola, right? So the hyperbola, it will be in the form of a over x plus q. Then the value of a must not be equal to 0. That's a hyperbola. So the a, this a here, the a that you see there, it's what we call a constant. This is a constant number. It's a constant number. And not only that, it also affects the shape of your graph. So we use A to know the shape of the graph. It affects the shape. Do you understand?
Yes.
Okay, so now, how about okay, I'm just gonna go through with you this one. So this is one of the most important things. This is where most learners, they start getting this question wrong. If you struggle with this one, then you won't understand the whole concept of drawing. Né? So if you are given y to be, let's say a is positive, you have a positive a, and the value of q, it's also positive. So here, in this case, you have a greater than 0, and you also have q that is greater than 0. How will the graph look like? So your graph will look like this. This is your x, this is your y. Then, because the value of q, this is your asymptote. The value of q will be your horizontal asymptote. Right. Since it's your horizontal asymptote, it will be above the x-axis. It will be somewhere here, above the x-axis. Are you following?
Yes.
Right. Another thing, if the value of a, if a is greater than 0, your graph will be in first quadrant and your graph will be in third quadrant. So meaning it will be in this quadrant, which is your first quadrant, and then it will be in this third quadrant. So I need you to understand something when it comes to this one, okay?
Yes.
If you look at this, we use this line, right? And we use the asymptote. This is how your graph will look like. You understand?
Yes.
Okay. So now I'll definitely send you this notes. I'll definitely send you the notes because it's very important that you understand this concept. So this is how your graph will look like. So now let's say that you are given y is equals to the value of a is positive, but the value of q is negative, meaning that from this, a is greater than 0, but q is less than 0. So now the shape of the graph will be still in quadrant 1 and 3, but what changes now? It will be the vertical asymptote. Okay, let me quickly write this down. So the only thing that changed, the vertical asymptote, so this is your VA, it will be below. If this is your X, it becomes below the X-axis. I'm not sure if you can see the difference. But your graph will still be in first quadrant, but it should not touch that dotted line, and it will be in quadrant 3, but it should not touch the dotted line. So when we do the quadrant, we look at the dotted line, which is this one, and this line here. Do you understand?
Yes.
Is this making sense?
Yes.
Do you have any questions?
So, sir, well, so in a sense, they never really changed directions because they only moved up a little bit up and a little bit down
Ex-
when A
Yes.
was greater. So they'll never fully change direction.
Uh, I'm going to answer your question now. Let's work if the value of A is less than 0 so that you can see how they change the direction, okay?
Okay.
So one thing you need to know is that Q is your asymptote. It moves the graph up and down.
Yes.
Okay. Okay, let me just write this one. And then if this one, if I look at this one, this will be y. It's equals to minus a over x, right? And then
Yes.
this is minus q. So from this graph here, now the difference this time is that the value of a is negative, right? So
Yes.
a is less than 0 and also q is less than 0. 100%, okay? So now what I need you to note is that if the value of a is less than 0, your graph will be in quadrant 2 and 4. Do you understand?
Yes.
So remember, at first, if A was positive, it was in quadrant 1 and 3. But if A is less than 0, the graph becomes at quadrant 3 and 4. So to write this down, this is how your graph will look like. Let me quickly write it down for you. So this will be the graph. This is your X, this is your Y. and then look at the value of Q is negative. And we said that if the value of Q is negative, the asymptote will be below the x-axis. Do you understand?
Yes.
Then, since the value of A is less than 0, our graph will be in quadrant 2, but it should not touch the dotted line, and it will be in quadrant 4. You understand?
Yes.
So this is the difference between the first one. You see how it changed?
Yes.
Okay, let's work on the second one, which will be the last one. Then we can call it a day. I'll see you next week. Not next week, tomorrow. Okay, so this will be y. It's equals to minus a over x, but this time the value of q is positive. So remember, since q is positive, the asymptote becomes above. It will be above the x-axis. Okay, that's the asymptote. Then your graph, it is still in quadrant 2, but it should not touch the dotted line, and also this line here, it must not touch. Then it will be in quadrant 4. Can you see that?
Yes.
I don't want to add too much information on this one. We'll definitely take it from here on our next lesson. So for now, what I need you to understand is that the domain of the hyperbola is always the same, and the range is always the same. It does not change. The domain will always be x must be an element of real number, but x must not touch 0. It must not touch 0. X must not be equal to 0. As you can see, we don't have a part where the graph is touching this blue line. It must not be 0. Remember, this is 0. So your x must not be 0. All of this graph, they must not touch 0. All of the graph, they must not touch 0. If we go back up, all of this graph, they must not touch 0. All of the graphs must not touch 0. Do you understand?
Yes.
Okay. The range will be y must be an element of real numbers always, but your y must not touch the asymptote, which is q. So whatever value of q that is given, all the graphs must not touch that value of q. So what I'm trying to say is that if you have y to be equals to 3x, 3 over x plus q, 3 over x plus 1, meaning the range will be y must not be equals to, y will be element of real numbers, but your y must not be equals to 1. Do you understand?
Yes.
But we'll talk about that on the next coming lesson, where I'll be explaining the axis of symmetry, and we start with the plotting. Okay.
Yes.
Yeah, for today, this is where we're gonna stop. Do you have any question based on what we've covered today?
No.
You're good.
Yes.
You sure? Let me send you the notes, man.
Okay, sir. Thank you.
Thanks. Have a great day. I'll see you tomorrow.
You too. Thank you, sir. Bye.
Sharp, sharp.